Talking about solving a 3 by 3 system of linear equations. Okay, very similar to a 2 by 2, but this time, like I said, it's 3 by 3, so you're dealing with um, three unknowns, okay, three equations. And like before, when we were trying to um, get the augmented matrix so that you have ones in the diagonal, zero in that bottom left corner, and whatever else. Everywhere else is still in the same process. You still want zeros in your bottom corner, but this time since it's a 3 by 3, it's basically in this bottom triangle where you want zeros. Okay? So there's a 1 in the top left corner and a triangle of zeros in the bottom left corner. Okay, it's called row echelon form. A unique solution would be where you have ones in that diagonal, very similar to a 2 by 2. This time it's just a 3 by 3, where you have the ones and a diagonal produce a unique solution, and you still have your triangle of zeros. Okay? So we're going to take a look at an example of a 3 by 3 system of equations. And with all the same row operations still apply. You can still interchange rows, you can still apply just one operation to a row, or you can apply an operation and then add or subtract another row. So then that way you can get a unique solution of the ones in the diagonal and a triangle of zeros. Okay? You just maybe have to do, instead of 2 or 3 processes, you might have to do 4 or 5, maybe even 6. It just depends on how difficult the 3 by 3 is. So taking a look at this, what would be the augmented matrix for this particular problem? Are you going down or across? All right, it's going to be 1, 3, negative 1. Very good.
2, 1, 1, 7.
Mm-hmm.
1, negative 1, negative 2, 0.
Very good. Okay, so if we look at this, what do you notice already? You already have 2 of the diagonal ones that are already there. You definitely have 1 in your top left corner. But do realize that any type of operation that you perform on the next row, it might change those ones. Okay? So our goal though is to make sure that this bottom triangle here are zeros, because then we'll be able to get our solution, and we'll work backwards. Okay? So we'll basically find z, plug it in, find y, and then find x to be last. Okay? Okay, so since you already have your first top left is already 1, okay? Like I said, your goal is to make sure that you get zeros in that bottom triangle, and then of course ones on the diagonals, okay? So if you're trying to look at the shortest way possible, you could have multiplied row 1 by 2, and then did the second row minus the first row, okay? So the operation, second row minus 2 times your first row, and that's going to replace your second row. So if I multiply my first row by 2, then that becomes 2, 6, negative 2, 15. And then I'm going to do my second row minus it. So minus all this. 1 minus all this. 1 minus all this. That's going to give me 0, negative 5, negative 3, and then negative 8 for my second row. Okay? So I don't alter my third row at all. For that third row, and that bottom left corner, that 1 needs to turn to a 0. How can I turn that 1 into a 0? What could I do? Subtract the first row from the third row. So would that be R3 minus R1 or R1 minus R3? and that's gonna replace row 3. Okay, so 1 and 2 don't change. Positive 15, -8.
Oh, man.
So when I subtract 3 from 1, what's 1 minus 1? 0. What's negative 1 minus 3?
Thankful.
What's negative 2 minus a negative 1?
Thankful.
And what's 0 minus 15? 15. So far I got my 2 zeros. Now I need that negative 4 to become a 0. Okay? I'm definitely going to work on the zeros first, because if I did try to change that negative 5 to a 1, in order for me to probably turn that bottom row into the zeros that I need, I'm probably going to, it might be a little bit too hard to try to avoid changing that 1 there. So it's easier to make the zeros and then get the 1s. Okay? So how can I turn that negative 4 into a 0? Whenever you're ready. Say again?
Well, if you want to make it real complicated, you could times our row 3 by 3 over 4, and then add, or wait, hold up. Give me a second. I'm not very sure anymore.
Okay. Let's not make it too difficult. I'm trying to basically make this to be a 0, so why not I multiply the first row by 4, and then add it to the third row by 3. And replace row 3 with that. Mm-hmm.
I tried to do it times by 4.
What?
So I'm going to multiply the first row by 4, so that's going to turn into a 4, a 12, a negative 4, and then what's 15 times 4? Help me out. 16. Thank you. And then what's 3 times row 3? Well, 3 times 0 is 0. 3 times negative 4 is negative 12. And I made a mistake. When I add this is supposed to become my third row. No, it's not going to be 20. This one's still going to be 0. This would be a negative 7, and this would be 15. But then I made a 4. So I don't want to actually work with row 1. I want to work with row 2. Because this first entry will be a 0.
Oh, 4 and 5.
So it will be, it would, instead of being 3 and 4, I'll need to use 4 and 5, and then row 2 and row 3. Question?
No, I was gonna say that.
Okay, so let me fix this. So I'm going to multiply row
2 by 4.
2 by 4, 3 by 5. This one needs to be a negative so it can work. Okay. All right. So let's do that. 32. So I multiplied the whole second row by 4. Then I'm going to multiply, to make it easier, I'm just going to multiply by negative 5, so then that way it could work. So 0, that turns into a positive 20, turns to a positive 5, 75. So then it gives me 0, 0, negative 7, and what's 75 minus 32? 43?
Yes.
Did I do my math right? Can someone double check?
Wait, are you? Negative 1.
Negative 1.
That's what I got. If I fixed everything that she told me to, I got negative 1.
I got negative 5.
Okay. So, gonna multiply row 1 by 2. And subtract row 2. And that's gonna replace row 2. Okay? So multiply row 2, row 1 by 2. 2, 6, negative 2, 30. Then I'm gonna subtract row 2. That's going to give me 0, 5, negative 3, 23. So I'm gonna just double check my math, make
You're
sure that
good.
I'm good.
Yeah, you're good.
You sure?
That's what I did, so I hope so.
So row 2.
Oh, yeah.
Okay.
Well, she changed it from the last one, I was still looking at the last one.
Okay.
All right. So then I'm gonna turn that 1 into a 0 in that bottom left corner. And I do that by what? Row what?
I don't want to be the one speaking to this.
So when I subtract, that becomes 0, -4, -1, -15. Yes? Okay. Then to change that -4 into a 0, I'm going to multiply row 2 by 4, row 3 by 5, and replace row 3 with it. $23 times 4 is what?
92.
Thank you. And then that gives me 0, 0, -17, and 92 minus 75, is that 17?
Yes.
There we go. So now we are where we need to be. We have -17. What's that variable right there? For that last column, what variable is that? It's z. Remember the 2 by 2 was first column was x, second column was y, third column is z. So we have -17, z equals 17, so z equals -1. We'll have 5y minus 3 times -1 equals 23. 5y plus 3 equals 23. 5y equals 20, so y is 4. And then plug into the last one, that's x plus 3 times -1 minus 1 times, 3 times 4, -1 times -1 equals 15. X plus 12 plus 1 equals 15. X is going to equal what? There we go. All right, so we didn't have to get the diagonals 1. In this case, we didn't have to because when we had our 0, 0 here, and then we could just set that last equation equal. If we did get to ones, we would have to multiply that second row by 1/5, that third row by -1/17, and it would have been a little bit easier on this part of the process. If we did get it all to be ones, it would be less algebra here. But no, we didn't necessarily have to.
You don't
Mm-mm.
ever,
It-
or just in this problem? Or you
I think for this problem, we didn't have to. I'm not gonna say ever. It'd be that one example that makes it sometimes, not always. If I did multiply row 2 by 1/5 and row 3 by -1/17, I would have that z is equal to 1 When you plug in, then you'll have y equals,
I think you meant -1.
yeah, because I've got that, sorry. Then you'll have y plus 3/5 equals 23/5. Then you would subtract, and you still get 20 over 5, which is 4, and so on and so forth.
I did the one thing earlier on.
Mm-hmm.
I did do the line.
You got the ones, and you still know the same answer? Yeah. So you still get the same answer, yes. All right? Just don't make the mistake that I did and mess up on your algebra, especially in the early steps. Of course, you can have no solution to infinitely many solutions in a 3x3. That's no solution would be zeros all the way across the bottom with the ones in the diagonal, and then a non-zero in that one spot, as you can see in the first picture, or a 0 in the second spot and a non-zero there, or zeros all along the bottom and zeros on the left side of that vertical bar and a non-zero there, as you can see.
Does it have to be the bottom row?
It does have, well, it doesn't have to be if you have that second situation and then a non-zero there. But no, yeah, bottom needs to be zeros. Because that basically means that all your variables cancel out. For infinitely many solutions, okay, that's zeros all the way across the bottom. Zeros all the way across the bottom, because that basically means a 0 equals 0. And we express the solution in these cases in terms of parameters such as S and T, which we talked about Tuesday, the last time I saw you guys. Okay? So remember, that's when we make one of our variables, one of the parameters, either S or T, and then we basically create a general expression to represent the solutions. Okay, we talked about that right before we went over your test on Tuesday. All right, so let's look at an example. I'm going to build examples for here on out. Okay, we're going to solve
I'm gonna take a wild guess.
this 3x3 system.
I'd say this is an impairment system.
Okay. You guys want to try this one on your own? You want to do it together? Do it together?
I'm sure.
Okay. Let's make this 0. How can I make this 2 a 0? Three R2 minus 2R3? Yes. 2R1 minus R2? Both of those will give me 0. Both of those will give me 0. And then it'll give me a different second and third spot. Can I do the second option? Less multiplication? Which was R1 times 2 minus R2? Okay. We know how my math is, so I'm going to let you guys do that and tell me what row 2 is. What'd you get? 0, 5, 1, -2? Yes? Yes or no?
Yes.
Okay. So we got 1 0. How do I make that 3 a 0? Okay. Let's do the math. What we get? 0, 10, 2, -9. Yes? Now what? R3 minus 2R2, and that's going to replace what row? The third row, okay? Let's do the math. What do we get? Zeros along the bottom. What about here? What? -5? -5. So what does that mean? This system is called what? Inconsistent. Very good. Let's do another one. Ready? Thank you. Let's try this one. You want to try it on your own? Okay.
So,
It's supposed to be 1/3. Well, it's supposed to be a negative 1/3. T minus 1/3. Yeah, it's a negative 1/3. What do we do?
Hold up.
And then we divide it into
No.
right?
Is this the
Yeah, what's
minus 1 half.
We've got every digit for the second row, like.
I don't even want to talk about the second row right now. My second row is beautiful.
That's in the second row, so I'm like,
More?
no, like to finish the problem. Like one more.
Why did you do R
Fine.
and I do R?
That's what she's talking about the parameter part.
Yes.
Take your notes.
And you,
Sorry, mine.
oh, I might have just wrote,
Because the last step is not hard at all.
Don't write.
oh, what is it? Yeah, I just forgot to write the 2.
Dang, she got that.
Oh, yes.
No, yes, I don't know what's going on yet.
Okay, look.
What?
So it looks like that's my entirety of notes for parametric form.
Okay, if I have no
Okay,
way
so we
of
take the second row and we have
I have no way of
y
solving for y.
minus z
No, y equals
equals.
t minus 1/3. So whatever z.
Yeah, it's supposed to be got
Yeah.
I have,
I have negative
So-
integral, you have
That's
negative
making
1/3,
sure
I know.
Where's
We're
your
on three now.
Can you read
We
the
did some
bottom
crazy
right?
crap, so.
It's basically
It did.
the constant
Okay.
minus 1/3.
So it looks like
Okay,
if
that's
y
pretty
equals t, z,
I just
Y
completely
has to
forgot
equal
about that
t?
part.
no, why don't we make
Okay,
z
okay.
equal t?
See, the difficult
Because these
problem
the
is not
second
able to do that.
Yes.
Difficult problem
So
is
y equals
not making a mess or mistake.
equals t minus 8/3.
I think you should go sit violation of that.
I have absolutely no clue what I'm doing, but I'm
Do
attempting.
you guys know what you're doing?
Yeah, we're done.
Yeah.
That's great. You want to explain something?
Well,
she's about to.
About to.
What the heck is parametric form?
Yeah, but we're gonna do it now. So I have the answer. Okay. Do you need to see
Hold
what?
up.
You have that right? Yeah, I got it.
So
Yeah,
now
now
you
you
have
have
to
to set up parameters.
So it has to equal whatever variable.
Okay.
Have it 8/3
Yeah.
and final form.
Then what you're gonna do, because c equals t, you're gonna move up and like this.
Okay, I have it.
Still have a y.
Yes.
Right?
I have a y.
Why do we need
t?
Yes. So, but c equals t, so you're gonna put t, you're gonna plug in t instead of g.
It makes sense when you get to x.
Okay, so instead it's just gonna be y minus t equal negative 1/3.
And then solve for y.
Yep.
Solve for y.
Solve for y.
Okay.
And then do the same thing for x.
And
Okay.
then just keep plugging it in. And I'll use every single one.
What's happening?
So z has to equal something, right? So we're gonna make it equal to t. Yeah. And then we're gonna plug a t instead. Then we're just solve for y.
Y equals t, maybe minus 1/3, maybe minus
It makes
8/3.
sense now, after I did that math.
Someone's really wrong.
That's a really bad
I
math.
think it's me, but I don't know where I did wrong.
Where it did wrong.
I have 2 examples of this.
So what's the solution here?
Oh my god.
There's infinitely many because you have
She has mine. I'm right.
because you have zeros all along that bottom row. But remember, like was stated before, we express the solution in these cases as parameters such as s and t. So what parameter am I going to use, s or t? T, to be honest, it really doesn't matter.
Okay.
Alright.
About to say,
It says, usually use two parameters, it's like you have like two different, like, situations going on, like two different sets of equations. Okay, but in this case, it's only gonna be one, either S or T, yeah. You'll see when we do other things, how you'll have different. So then now, we gotta express as parameters, so Z is gonna be expressed as T, which means that if you go backwards here, at least for mine, I don't know how you guys had, I'm gonna have Y minus T equals a negative 1/3. So when I solve for Y, I'll have Y equals T minus 1/3. Yes?
Yeah.
Okay, so Z is equal to T, Y is equal to T minus 1/3. And then I'm gonna go back and I'm gonna plug it back in up here, so to X minus T minus 1/3 plus T equals 5. Could have done probably a little bit more row operations, but I just stopped once I got the 1 there. So then this gives me, so I don't want to mess up on any of my math. T's cancel out. And when I add the 1/3 over, it becomes, subtract the 1/3 over, that gives me 14/3. Then divide by 2. X is equal to 7/3. Is that what you got? Okay. You might not have gotten the same route as me because, like I said, there's many ways to do your row operations depending on how you see. But then at the end, we should all end it with infinitely many solutions with the same type of solutions parameter, parametric solutions. Let's look at one more solution. One more.
I don't know. Can I do another one? Can you do
I'm gonna jump that other one, and we're gonna do this one because I want to make sure that.
I literally had a break.
So, yeah, A cannot equal 29. Okay. I wanted to know if 29 was the number.
My brain actually hurts. Okay,
Can you do like the parametric forms? Okay, look. So, if,
I did this.
yeah, you solved A and B.
A, B, C.
Now C, A equals 29.
Brain really many.
Yes, but I think we have to solve it too.
Oh, I prefer two. This would take me an entire, like,
Okay.
this would take up my
X,
entire.
Y, plus B.
Are you done? No. See, on a test, it should be
So
negative
X
5.
minus
It's fine,
plus
it's fine. You still get the same answer.
equals negative, hold
Why don't you
up.
just
No,
What did you
negative
get?
5. I think there's two negative 5.
X minus T equals 5,
Multiply for whatever.
X equals.
So now.
Under what condition?
Hold up.
Under A
What do you
equals
think
29,
X
yeah?
equals?
Find the solution. So we just plug in.
Get down to this point where you have zeros on the bottom and a minus 29 on the bottom row?
Yeah.
Okay. Good stuff. Time? What's the time? Thank you. What's the fifth of this? 30. Wow. Alright. So, there we go. Okay. That's as far as you want to go, okay? Technically, you have your zeros in your corners, your ones technically would have been your diagonal, but we do have zeros all the way across. So, for what values of A does the system have no solution? As we can see, it's going to have no solution. When A is what?
Not equal to 29.
When A is not equal to 29, because basically that A minus 29 would have to equal 0 in order for it to be, would not need to equal 0 for it to be no solution. It would need to be some other number because there's zeros there. So then that's why A does not equal 29. And under what conditions does the system have infinitely many solutions? And find the solutions in these cases. What'd you get?
A equals 29. It's infinitely many. And then Z equals T, Y equals 3 minus T.
Z equals
T.
T,
Y equals 3 minus T.
because we would plug in T plus, no. Fix it. Then we would use that equation here. Y minus T equals 3 plus T. So then 3 minus T, or negative T plus 3.
And then X equals 5 minus T. It's a plus 2T minus 2T.
Thank you. So then this would be a plus T here. Thank you for that. You said a 5 minus T?
Yeah.
Here we go. Questions?
I have no clue.